All right, let's continue with compound inequalities. Here's a couple of different types than we've seen in the previous one. And or. So here we'll actually see the word and or in the inequality. Ands work like the ones we saw previously where we had kind of the three sides, a number less than or equal to another number or expression less than or equal to another number or expression. And, so if we have the and of different inequalities, this is going to mean the intersection of the solution sets, or the x values that solve both simultaneously. Those x values they have in common, in other words. So for this we want the common, another n there, or the intersection. Or x values could solve one or the other. Either would make it a part of the solution set. So when we find the solution sets for the or, we want the union, or all the solutions, right, from either solution set. Okay, so and, intersection, or union. Okay, let's solve these. The way we'll go about it is we'll solve each inequality, then we'll get the solution set for each one, and then depending on the conjunction symbol, the and or the or, we will either take the intersection or the union of those solution sets. We'll find the points in common, or we'll take the whole thing, right, in a union. Okay, so let's try this. So we've got negative 2 times the quantity x minus 1 is less than 4, and 6 plus x is less than or equal to 9. Okay, so we have an and inequality. That means we're going to take the intersection. Let's solve both inequalities. Okay, first off, let's distribute the negative 2. So we have negative 2x plus 2. Right, so negative 2 times negative 1 is plus 2. And then less than 4. We can subtract 2 from both sides. So we have negative 2x less than 2. And now we want to divide by negative 2, and we have to be careful. We're dividing by negative 2. We have an inequality, and so we have to switch the inequality symbol when we do that. So x is greater than negative 1. Okay, so that's one inequality solved. We'll solve the other one. This one just needs us to subtract the 6. So x is less than or equal to 3. All right. So we have that x is greater than negative 1, and x is less than or equal to 3. All right, let's go ahead and draw the number line solution first. So negative 1 and 3. And let's go ahead and plot both of those in different colors. All right, let's start with this one. So x is greater than 1. So what we'll do is we'll put parentheses here, and then greater than 1. And then we have x is less than or equal to 3. So we want brackets here, and then less than or equal to 3. Okay. And so the answer, or the question then is, what is our solution set? Well, since the conjunction here is and, right, we only want values that solve both inequalities simultaneously. So those numbers are those between negative 1, right, not including negative 1 because that does not solve the first inequality, up to 3, but including 3 because 3 solves the first inequality and also solves the second. Right? So the solution in interval notation is negative 1 to 3. Parentheses on the negative 1, brackets on the 3. Okay, so this is the general procedure that we're going to use. We'll identify the conjunction, solve both of the inequalities, then graph them on a number line, and then depending on the conjunction here, either take the union or the intersection as we did here, to get the solution set. Okay, let's do another one. If you like, you can pause the video right here and try this one. Okay. So here we have an or conjunction, so that's going to be the union. And anyway, we'll solve both of these. So we're going to subtract 3y. Oh no. Let's subtract the 2. We don't want to do more work than is necessary. So 3y is less than or equal to 15. Okay, we can divide by 3. We have y less than or equal to 5. Good. Okay, over here we need to subtract the 2. So we have negative 5y less than or equal to negative 50. And now we need to divide by negative 5. But to do that, we have to switch the inequality symbol because we're dividing by a negative number. So we'll have y greater than or equal to 10. All right, let's draw out the number line. So got our number line, got 5 and 10. And we want y is less than or equal to 5. So we start here. So this is inequality, brackets, because we have the non-strict inequality, and less than 5 goes this way. And then y is greater than or equal to 10. So again, brackets, this way. All right. And the conjunction here is or. That means we take the union of the two. So to write the answer in interval notation, we'll go negative infinity to 5, bracket, union, 10 to infinity. All right, good. Okay, let's do a couple more examples. Again, if you like, go ahead and pause the video right now and solve both of these. And when you start up the video, we'll work on them. All right. So here we have an and, so it's a conjunction. We want the intersection. We'll start with this first inequality. So 5n plus 6 all over 3 less than, strictly less than, negative 10. And negative 3 times the quantity and minus 1 is strictly less than negative 6. Okay. The first thing I want to do is get rid of that fraction. Let's multiply both sides by 3. So 5n plus 6 strictly less than negative 30. Can subtract 6 from both sides. 5n strictly less than negative 36. And we can divide by 5. So n is less than, strictly less than negative 36 over 5. All right. Other one here. So we have negative 3n plus 3 strictly less than negative 6. Could subtract the 3, so we get negative 3n strictly less than. So if you subtract 3, we get negative 9. And then if we divide by negative 3, we have to remember that we need to switch the inequality symbol. So n greater than 3. All right. Let's plot these on a number line. So we have n greater than 3. So let's put 3 here. Then we have negative 36 fifths. That's going to be a little bit less than 7, negative 7, because 7 times 5 is 35. Okay, so we got strictly greater than and strictly less than here. Okay, and we want, from the conjunction here, and, which means we want the intersection. And so we can see that these two intervals here are disjoint, as in they don't have any overlap. So there's no points in common here. No common points between these two. So there's no value of n that solves both of these. And so we can say that there is no solution. And that's typically given with the empty set symbol. All right, let's work on this last one. Here we have -2 times the quantity a minus 1 is strictly less than 4, or 6 plus a is less than or equal to 9. All right, distribute the 2, so -2a plus 2, strictly less than 4, -2a, strictly less than 2. We subtract 2 from both sides, and we can divide by -2. A is greater than -1. Note the change of the inequality symbol after we divide by -2. Okay, next one here. Subtract 6. A is less than or equal to 3. All right. So we have a greater than -1, so there's -1. 3. So a is greater than -1. Okay, so parentheses here. And greater than -1. Okay. And a is less than or equal to 3. Okay, so we need to start at 3, include 3, and go this way. All right, so you can see there's some overlap for our intervals here. The conjunction is or, which means we want the union. So values that solve both of these or either of these inequalities would be in our solution set. Since the entire number line is covered, right, there's no value that can be plugged into at least one of these inequalities. The solution is all real numbers. So we'll go ahead and write that -infinity to infinity as our solution. All right.